So one of the interesting little features of Lucee CFML is this local mode directive that you can attach to a function, or it's something that you can attach at the application level itself. And what this local mode of modern does, as opposed to classic, is determine what an unscoped variable assignment does in the context of the function execution. Historically, ColdFusion will take an unscoped variable assignment and apply it to the variable's scope. By using local mode modern, it takes that unscoped variable assignment and applies it to the local scope of the function itself. Now, it occurred to me that one of the ways that this could be used is to make it safer to dynamically render ColdFusion templates. So to see this in action, I have this render template with this local mode modern here, and it's going to accept some number of arguments. It's then going to include this ColdFusion template, and instead of outputting that to the browser, it's going to save the output of that template evaluation into this output buffer, and then it's just going to return the output buffer. And then you'll see here that I'm calling render template. I'm saving the rendered content into the variable scope, and then I'm dumping out the variable scope. And the goal here is just to see what ends up in the variable scope after we call this function with this local mode and this template execution. Now let's take a quick look at what template's doing, because there's some interesting stuff there that I think can bite people a lot. So here's my template.cfm, and you can see one of the things it does is it might use the param tag to assign a default value. And in this case, this categorization value is going to end up in the variable scope, or could theoretically end up in the variable scope. I also take an existing value and I map it onto another value, so this could also end up in the variable scope. And then here's the one that's actually quite tricky, or subtle I should say, and people don't realize. Here I'm going to take that variable and I'm going to loop over it, and I'm going to assign this iteration value. Now, no one really ever thinks about the iteration value, but this is a variable declaration, and that will typically end up in the variable scope as well. But given the execution here with local mode, let's run this and see what happens. So if we run this, we can see that in our variable scope of the calling context, we only end up with the rendered content, which is what I'm saving right here, and with the function declaration itself. Now let's compare that to a different test, which is going to use local mode classic, which is the same essentially as not having local mode at all, but I'm going to leave it in to be more explicit. And this again is the same exact, the rest of the code here is exactly the same. It's calling the same exact template. The only difference here is that I'm local mode classic, not local mode modern. And when we run that version and refresh, what you can see here is that we have not only the rendered content that I'm explicitly storing into the variables, we have that categorization, that was the CF param here at the top, is creating that categorization variable in that variable scope. We also have the friend, which of course is the CF loop iteration variable, and we also have my friends, which is the variable I'm declaring here. So essentially what we're seeing is that the dynamic rendering of a ColdFusion template can be made much safer in terms of polluting the variable scope when we're using that local mode is modern. And this is actually really important to think about, because when we have stuff going into a variable scope accidentally, that creates really subtle and can be very confusing race conditions, where you can actually get different values stored into the variables at unexpected times, and you can get this cross-contamination of requests in a multi-threaded environment, which is of course essentially what almost every ColdFusion application is. So this local mode modern, I'm pretty excited about thinking more deeply about that and how I can apply that in my applications going forward. Like I said, it can be applied at the function level, but it can also be applied in the application CFC for a cross-application setting. Of course, in a brownfield application, it doesn't necessarily make sense to be able to apply that to the entire application. You might get regressions that you're not expecting. So being able to do it at the function level allows you to sort of roll this out as needed, which is pretty nice.